Good morning all. So in today's class we will see a few more problems on solving the first order differential equation using power series. So the question is, consider the following differential equations. So we have xy dash equal to y and x square y dash equal to y. So in each case find a power series solution of the form summation a n x raised to n. Solve the equation directly and explain any discrepancies that arise. So let us look at the solution of the first equation xy dash equal to y. അപ്പം നമുക്ക് ചെയ്യേണ്ടതാണ് പവർ സീരീസ് സൊല്യൂഷൻ കണ്ടുപിടിക്കുക, ഡയറക്റ്റ് സൊല്യൂഷൻ കണ്ടുപിടിക്കുക. സോ see whether they are the same or not, and if they are not the same, so explain why. That's the question. So first question is xy dash equal to y. So our solution is of the form summation a n x bar n. So therefore y dash will be summation n equal to 1 to infinity n a n x raised to n minus 1 varum. Ni y um y dash substitute here. So upon substituting you will get x into a1 plus 2a 2x plus 3a 3x square plus 4a 4x cube plus etc. That will be equal to a0 plus a1x plus a2x square plus etc. Now equating the coefficients on both sides. So adding constants equate here. So you will get a0 equal to 0. Ini x in the coefficient equate you will get a1 equal to a1. Then x square in the edukumbo you will get 2a2 equal to a2. Then for x cube you have 3a3 equal to a3, so on. Okay. So when you solve for this equations, you will get a0 equal to 0. A1 will remain the same. You are not getting the value for a1. Then from the third equation you will get a2 equal to 0, a3 0 so on. All the other above values, all the an when you have a4 a5 a6 so on, so all of them are going to be 0. So therefore substituting these ai values in the given series, so remaining we have only so all are 0 except a1. So therefore the solution is y equal to a1x. So this is the power series solution. Now let us look at the direct solution. നമ്മൾ directly solve ചെയ്യുമ്പോൾ, so use variable separable method. So we have the equation x dy by dx equal to y. So dy by y will be equal to dx by x. So upon integrating you will get log y equal to log x plus, so let me take the arbitrary constant as log c. So you will get y equal to cx. So you can see that both the solutions coincide. So there are no discrepancies in this case. So both the solutions are the same. Now let us look at the second problem. So you have x square y dash equal to y. Again solution is of the form summation a n x raised to n. We have the value of y dash. So substitute y and y dash. Appo namakku x square into a1 plus 2a 2x plus 3a 3x square plus 4a 4x cube plus etc. So that will be equal to a0 plus a1x plus a2x square a3x cube plus etc. So equating the coefficients again, constant term equate a0 equal to 0 varum. Then when you equate the coefficient of x, again a1 will be 0. Now x square and equate you will get a2 equal to a1. So again a2 will be 0. Adutha coefficient edukumbo you will get a3 equal to 2 a2. So a2 0 aanu, a3 0 aanu. So you can see that all the ans will be equal to 0. So all the ans will be 0. So therefore the solution will be y equal to 0. So y equal to 0 is the power series solution obtained. Now let us look at the direct solution. Now when you solve the equation directly, again we can use variable separable method. Upon dy by dx ne, so that will be y by x square. So separating the variables you will get dy by y equal to dx by x square. Now upon integrating you will get log y equal to, so this is minus 1 by x plus log c So log y by c will be equal to minus 1 by x. അപ്പോൾ നമുക്ക് y ന്റെ value c e raised to minus 1 by x. Okay. And now here you can see that the power series solution is y equal to 0, but our direct solution we have obtained is y equal to c e raised to minus 1 by x. Now you can see that y equal to c e raised to minus 1 by x. So when you expand this as a series in powers of x, you can see that it has negative powers of x. അപ്പം നമ്മൾ e raised to minus 1 by x expand ചെയ്യുമ്പം x ന്റെ positive powers അല്ല വരിക, x ന്റെ negative powers ആയിരിക്കും വരിക. That means your given function is not analytic at x equal to 0. അപ്പം provided this function has to be analytic at x equal to 0, നമ്മുടെ arbitrary constant 0 ആയ മാത്രമേ, അതായത് c 0 ആയ മാത്രമേ ഈ ഫംഗ്ഷൻ 0യിൽ അനലറ്റിക് ആവുള്ളൂ. അപ്പം this is not analytic at x equal to 0. അതുകൊണ്ടാണ് നമ്മൾ പവർ സീരീസ് സൊല്യൂഷൻ എടുക്കുമ്പോൾ you are assuming that your function is analytic at x equal to 0, but that does not happen. So it happens only when y is equal to 0. So that is the discrepancy which arises here. So the power series solution is y equal to 0. So we do not get y equal to c e raised to minus 1 by x as power series solution, since y equal to c e raised to minus 1 by x is not analytic at x equal to 0. So this solution becomes analytic at x equal to 0 only when c is 0. So both the solutions will be the same only when c is 0. അതിന്റെ റീസൺ ഇതാണ്, നമ്മൾ പവർ സീരീസ് സൊല്യൂഷൻ അസ്യൂം ചെയ്യുമ്പോൾ we are assuming that the solution is analytic, but here this function is not analytic at 0. So let us look at the next problem. So you are given the equation y dash equal to 1 plus y square. So y dash equal to 1 plus y square is non-linear, and it is easy to see directly that y equal to tan x is a particular solution for which y of 0 is 0. So you need to show that tan x is equal to x plus x cubed by 3 plus 2 by 15 x raised to 5 plus etc. by assuming a solution for 1 in the form of a power series summation a n x power n and finding a n in two ways. So tan x is already a solution for this equation. So we need to show that this is the power series solution, x plus x cubed by 3 plus 2 by 15 x raised to 5 plus etc. So therefore tan x will be equal to this. You are asked to find a n in two ways. First way of finding a n is നമ്മൾ ഇത്ര നേരം ചെയ്ത പോലെ തന്നെ കോഎഫിഷ്യൻസ് ഇക്വേറ്റ് ചെയ്ത് a n കണ്ടുപിടിക്കുക. Now the second way is by differentiating 1 repeatedly to obtain. So in the equation 1 you are given y dash. So upon differentiating you will get the second derivative, then you can find the third derivative, so on. And then this is using the Taylor expansion. അപ്പം നമുക്ക് a എന്ന് പറഞ്ഞാൽ fn at 0 by n factorial ആയിരിക്കും. So using that way you need to find a. So let us look at the values of a n. So first we will do by equating the coefficients. അപ്പോൾ ആദ്യം നമുക്ക് y ഡാഷിന്റെ വാല്യൂ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. So y is summation a n x raised to n, y dash is summation n a n x raised to n minus 1. Okay. അപ്പോൾ y ഉം y ഡാഷും സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. So this is y dash 1 plus y square വരും. അപ്പം നമുക്ക് സീരീസിന്റെ സ്ക്വയർ വരും. So let us write a few terms of the series. So on the left side you have y dash, and on right side so you have 1 plus. So I have written a few terms. So you will have a naught square, then 2 a naught a1x, then you will have a1 square x square, then 2 a naught a2 x square, then a2 square x raised to 4, then 2 a1 a2 x cube, 2 a naught a3 x cube plus etc. ഇനി നമുക്ക് ബാക്കി കോഎഫിഷ്യൻസ് ഇക്വേറ്റ് ചെയ്യാൻ നേരം കറസ്പോണ്ടിങ് coefficients ഇവിടെ നിന്ന് എഴുതാം. So ആദ്യം constants equate ചെയ്യുക. Constants equate ചെയ്യുമ്പോൾ you will get a1 equal to 1 plus a0 square. ഇനി here you are given the initial condition y at 0 is equal to 0. അപ്പോൾ y at 0 എന്ന് പറയുന്നത് a0 ആണ്. So നമുക്ക് this is the value of y. So that is a0 plus a1x plus a2x square. അപ്പോൾ x equal to 0 ആകുമ്പോൾ നമുക്ക് y യുടെ value a0 വരും. So a0 is 0. So when a0 is 0, a1 will be equal to 1. So we have obtained the value of a1. ഇനി അടുത്ത് നമുക്ക് x ന്റെ കോഎഫിഷ്യന്റ് എഴുതാം. x ന്റെ കോഎഫിഷ്യന്റ് എഴുതുമ്പോൾ you will get 2a2. x ന്റെ കോഎഫിഷ്യന്റ് ഇവിടെ 2a0 a1 വരും. So again a0 is 0. അപ്പോൾ a2 0 ആവും. ഇനി next is take the coefficient of x square. അപ്പോൾ 3a3 will be equal to a1 square plus 2a0 a1. So this is 0 and a1 is 1. അപ്പോൾ a3 will be 1 by 3. അതുപോലെ അടുത്ത് 4a4 will be equal to 2a0 a3 plus 2a1 a2. So that will give a4 equal to 0. കാരണം a0 ഉം a2 ഉം 0 ആണ്. So again 5a5 will be equal to 2a0 a4 plus 2a1 a3 plus a2 square. So second term non-zero ആണ്. So a5 will be 2 into 3 by 5 വരും. So that is 2 by 50. So substituting the terms, we have obtained till a5. So upon substituting, you will get y equal to x plus 1 by 3 x square plus 2 by 15 x raised to 5. Now, ഇവിടെ നമുക്ക് y equal to tan x already solution ആണ്. So therefore tan x will be x plus x cube by 3 plus x 2 by 15 x raised to 5 plus etc. Please write that step also. Okay. Now let us do by the second method. അപ്പം y dash is 1 plus y square. അപ്പോൾ y dash is 0, 1 വരും കാരണം y is 0 is 0. Now taking the second derivative, y double dash will be 2y y dash. So y double dash of 0 will be 0. Then take the third derivative. Third derivative is 2y y double dash plus y dash square. So third derivative will be 2. അതുപോലെ fourth derivative എടുക്കുമ്പോൾ you will get 2y y triple dash plus 3y dash y double dash. So again ഈ term 0 ആവും. So y4 at 0 will be equal to 0. Again when you take y5 and differentiate y4, so you will get 2 product rule apply ചെയ്യുമ്പോൾ you will get 2y into y4 plus y3 into y dash വരും plus 3y double dash square plus 3y dash y3. അപ്പോൾ y dash y3 യുടെ term non-zero ആയിരിക്കും. ഇത് രണ്ടും 0 ആവും. So y dash y3 will be 2. So you'll get 2 plus 3 into 2. So that will be 16. So therefore by using the Taylor expansion, your solution will be y equal to y0 plus y dash of 0 into x by 1 factorial plus y double dash of 0 by 2 factorial into x square plus y double dash of 0 into x cube by 3 factorial plus etc. So substituting the value of derivatives, you will get 0. രണ്ടാമത്തെ term x by 1 factorial വരും. Then second derivative is 0. Third derivative is 2. 2 by 3 factorial x cube. Fourth derivative is 0. Then fifth derivative is 16. 16 x raised to 5 by 5 factorial വരും plus etc. So upon simplifying, you will get y equal to x plus x cube by 3 plus 2 by 15 x raised to 5 plus etc. So therefore again y equal to tan x ആയതുകൊണ്ട് this will be the solution. This is an exercise. Okay, so you need to solve the equation y dash equal to x minus y. You are given y at 0 equal to 0. അപ്പോൾ നമ്മൾ ഈ ചെയ്ത രണ്ട് മെത്തേഡിലും സോ ഫസ്റ്റ് കോഎഫിഷ്യൻസ് ഇക്വേറ്റ് ചെയ്ത് a ന്റെ വാല്യൂ കണ്ടുപിടിക്കുക. ആൻഡ് സെക്കൻഡ് ഇസ് യൂസിങ് ദിസ് മെത്തേഡ് ടേക്കിംഗ് ഡെറിവേറ്റീവ്സ് ടെയ്ലർ എക്സ്പാൻഷൻ പോലെ ചെയ്ത് കണ്ടുപിടിക്കുക. സോ ഫൈൻഡ് ഔട്ട് ദി റിസൾട്ടിംഗ് സീരീസ് and verify your equation directly